Say Gujarati, and most people picture one genetic story. Indus Valley roots, maybe a little Persian trade blood folded in somewhere along the way, and that's the whole account, done and settled. It's the assumption baked into pop history, into DNA kit marketing, into casual dinner table certainty about where a Gujarati bloodline begins and ends. But a 2026 paper, one that sequenced 168 complete mitochondrial genomes from across Gujarat, just took that single tidy story and split it into at least 6 separate, traceable ancestries. Bantu Africa shows up in the data, so does Sassanian Iran, so does the Central Asian Steppe. And underneath all of it sits a maternal lineage that traces back 40,000 years, one that appears to have never left the region at all. So which Gujarat are we actually talking about? The coastal trading hub, the ancient refuge population, the crossroads of 3 continents worth of migration, or something none of those labels quite captures? This isn't folklore dressed up as science. It's published research, appearing in the American Journal of Biological Anthropology in 2026, built by 16 researchers working across 9 institutions. That's not a fringe claim slipped into a blog post. That's a coordinated, peer-reviewed effort to actually map what's inside Gujarati DNA, lineage by lineage, migration by migration. And the paper's own numbers turn out to be stranger than the myths they replace. If genetics meets history is your thing, you're in the right place. Hit subscribe and let's get into the DNA. Most popular accounts flatten Gujarati identity into a single phrase: descendants of the Indus Valley. That's the shorthand used in pop history videos, in consumer DNA test marketing copy, in casual assumptions about where the story starts and stops. The Harappan Ancestry Project, a consumer genetic calculator, offers a different picture even at that surface level. Its estimate puts average Gujarati composition at roughly 81.9% South Asian, 7.6% European, 4.9% Southeast Asian, 2.8% Austronesian, 2.3% West Asian, and 0.4% Northeast Asian. That's 6 categories already, not 1, and that's before any peer-reviewed research even enters the conversation. Worth flagging honestly, those consumer calculator figures are illustrative, not peer-reviewed science. And they shouldn't be mistaken for the real academic baseline. The real baseline runs deeper and stretches back further than a marketing tool. Gujarati Indians from Houston, known in the research world by the shorthand GIH, were one of the original reference populations in the 1000 Genomes project. That means Gujarat's DNA has functioned as a global genetic yardstick since the early 2010s, a fixed point that researchers studying entirely unrelated populations have measured against for well over a decade. There's an irony sitting right in the middle of that fact. The world has used Gujarati as a genetic reference point for more than 10 years, without any real agreement on what that reference actually contains, what lineages it's built from, or how many separate histories are folded into it. That's the real question this episode is built to answer. Not where do Gujaratis come from, in some singular sense, but how many separate migrations had to happen, layered one on top of another across thousands of years, for the word Gujarati to mean anything coherent at all. The reference population the world has quietly relied on for a decade turns out to be the most genetically layered population in South Asia. The scene shifts to the lab, where that layering finally got mapped. The study behind this episode comes from Desai, Alqaisi, Singh, and their co-authors, published in 2026 in the American Journal of Biological Anthropology. Their approach was direct. Sequence complete mitochondrial genomes from 168 living individuals located across Gujarat. Then see what those genomes actually contained once compared against a much larger data set. That comparison set was substantial. Researchers cross-referenced their 168 samples against 529 additional mitogenomes, representing East Eurasian, West Eurasian, and South Asian lineages, giving them a wide enough net to place Gujarat's maternal ancestry in proper regional and global context. The headline split that came out of that comparison breaks down cleanly. 76% of maternal lineages found in the sample are South Asian or local in origin, 21% traced to West Eurasian sources, just 0.6% traced to East Eurasian sources. 3 numbers, 1 clear regional signature, but with real complexity sitting inside that 21%. The choice to focus on maternal, mitochondrial lineage rather than paternal lineage wasn't arbitrary. Women historically stayed more geographically stationary across generations, while men's lineages spread further and faster through trade routes and intermarriage. That difference in mobility means mtDNA tracks regional continuity with far more precision than paternal markers would, making it the right tool for mapping how long a population has actually stayed put. The researchers themselves noted something significant about the scope of their own work. This stands as one of the few widespread ancient genetics studies ever conducted specifically on this region. Most of what's been assumed about Gujarat's DNA up to this point was extrapolated from smaller, older sample sets, not from a dataset built at this scale. One detail inside that 21% West Eurasian component stands out. Roughly 19% of it arrived within just the last 5,000 years. The so-called foreign DNA in Gujarat isn't some distant echo from the deep past. It's overwhelmingly recent, and that recent 19% is where the paper starts naming names. The timeline pushes back further than 5,000 years, further than most narratives about Gujarat's ancestry are willing to go. The study frames the region's maternal ancestry as showing genetic continuity stretching back into the Pleistocene, into tens of thousands of years of unbroken presence, not just the few millennia typically discussed in conversations about ancient migration. Breaking down the dominant haplogroups found in the sample makes that continuity concrete. Haplogroup M accounts for 48% of the maternal lineages detected. Haplogroup R accounts for 28.5%. Haplogroup U accounts for 14%. All three are South Asia-associated lineages, and together they account for the overwhelming majority of what's present in the region's maternal DNA. Set against them are the smaller West Eurasian-linked haplogroups, H, HV, T, W, and U, all present in the sample but consistently detected at far lower frequency. It helps to be precise about what a haplogroup actually represents. It's a maternal lineage marker, one traced through unbroken mother-to-daughter transmission, connecting a living person back to a specific ancient population and a specific geography. It's a genetic paper trail, written in mitochondrial DNA, that survives essentially unchanged across tens of thousands of years. One finding inside that data stands apart from the rest. The subhaplogroup U7 appears in over 12% of Gujarat's sampled population, a figure higher than Punjab's 9%, and higher than the rates found in Pakistan, Iran, or Afghanistan. The researchers' conclusion from that number is direct. The data supports U7 having originated in Gujarat itself, not being imported from West or Central Asia the way earlier assumptions held. A marker researchers expected to trace back to Persia instead traces back to the Gujarat coastline. There's one specific haplogroup that decades of Indian population genetics debate have circled around: H2B. This marker has functioned for years as a kind of physical evidence, cited in arguments both for and against a large-scale Indo-Aryan migration into the subcontinent, treated by different sides of that debate as proof of their particular version of events. Placed against the dominant South Asian haplogroups found in this Gujarat sample, M, R, and U, H2B registers as a minority signal, not a majority one. It sits inside the wider 21% West Eurasian slice discussed earlier, one thread among several, rather than the entire fabric of that West Eurasian component. Population geneticists have increasingly moved away from treating single haplogroup arguments about Aryan ancestry as sufficient on their own, favoring genome-wide autosomal data instead, a broader kind of evidence that later segments turn to directly. There's a limit built into what mitochondrial data alone can prove. Because it tracks maternal lineage only, it can't settle debates that are fundamentally about male-driven migration patterns. That limitation is exactly why the paternal and autosomal record matters for the next stage of this investigation. To see the paternal side of that migration, the record has to go back to Haryana, not Gujarat. The scene is Rakhigarhi, Haryana, a site roughly 150 kilometers northwest of Delhi, and one of the largest settlements the Indus Valley civilization ever produced. Vasant Shinde led the excavation there between 2011 and 2016, digging into a site that had sat waiting for the right sequencing technology to catch up with what was buried in it. That sequencing effort turned out to be brutal. Researchers screened 61 skeletal samples pulled from the site and ran through more than 100 failed attempts before finally extracting usable ancient DNA from a single individual, a woman buried roughly 4,500 years ago. One success out of well over 100 tries, from remains that old, sitting in that climate, is close to the outer edge of what ancient DNA extraction can currently do. The resulting paper carries real weight in the field. Shinde and Narasimhan, publishing in Cell in 2019, titled it plainly, An ancient Harappan genome lacks ancestry from steppe pastoralists or Iranian farmers. The title alone tells most of the story, but the finding itself is worth stating in full. Her genome showed Iranian farmer-related ancestry combined with ASI, the deep South Asian hunter-gatherer component, and it showed zero steppe pastoralist DNA, not a Central Asian steppe migrant. An Indus Valley native, full stop. She wasn't an isolated case either. This individual connects directly to what researchers call the Indus Periphery Cline, a group of 11 additional individuals identified at sites in Turkmenistan and Iran, all carrying genetic profiles matching the Indus Valley civilization pattern. 11 more data points scattered across 2 other countries confirming the same genetic signature makes this far more than a one-off anomaly. It's a pattern, and a consistent one. Which raises an obvious problem for anyone trying to trace where modern Gujarat's genetic makeup actually comes from. If the oldest confirmed Indus Valley genome on record carries no steppe ancestry whatsoever, that steppe component showing up in Gujaratis today didn't come from this population, and it didn't come from this era. The steppe DNA modern Gujaratis carry had to come from somewhere else, later. The pivot here is direct. Back in 2009, Reich and his co-authors published a foundational paper in Nature, built on genetic data drawn from 25 different Indian population groups, and it reshaped how population geneticists talk about South Asian ancestry ever since. That paper established 2 ancestral poles. The first is Ancestral North Indians, or ANI, a population genetically tied to Central Asians, Middle Easterners, Caucasians, and Europeans. The second is Ancestral South Indians, or ASI, a population with no close genetic ties found anywhere outside the subcontinent. 2 distinct ancestral streams, one connected outward to a wide arc of Eurasia, the other rooted entirely within South Asia itself. The paper's central claim was sweeping in scope. Virtually every population sampled across India, without exception, showed some mixture of these 2 ancestral groups. Not a handful of communities, not a regional pattern. Every single group in the sample carried a blend of ANI and ASI ancestry in some proportion. The scale of divergence between these 2 ancestral populations is what makes the finding so striking. ANI and ASI are estimated to have split from a shared ancestor as much as 60,000 years ago, drifting apart for tens of thousands of years before any renewed mixture between them ever occurred. That's an extraordinarily long separation, long enough that when these 2 lineages did eventually mix, they were combining genomes that had evolved along separate paths for most of human history outside Africa. This matters specifically for Gujarat because of where Gujarat sits on the map. As a northwestern coastal state positioned along old trade and migration corridors, Gujarat occupies a natural mixing point between these 2 ancestral streams, a geographic crossroads where ANI and ASI populations would have had every opportunity to meet, intermarry, and blend. But the 2009 paper, for all its scope, left a critical question unanswered. It established that mixture happened. It never said when. That question, seemingly simple, required an entirely different kind of genetic math to solve. Dating that mixture required a completely different kind of genetic math. The fact lands cold. In 2013, Moorjani, Thangaraj, and Reich published a follow-up study in the American Journal of Human Genetics, expanding the original 2009 dataset from 25 Indian groups to 73. A much wider net, built specifically to answer the timing question the earlier paper had left open. Their method relied on a clever piece of genetic logic. ANI and ASI DNA segments in modern genomes shorten predictably over successive generations, broken down bit by bit through recombination each time DNA gets passed on. By measuring the length of those surviving segments in living people today, researchers could calculate, with reasonable precision, how long ago the mixture between ANI and ASI populations actually occurred. The dated window that emerged from that math places major ANI-ASI admixture between roughly 1,900 and 4,200 years ago, a span of well over 2,000 years during which this foundational mixing happened across the subcontinent. The geographic pattern inside that window is just as revealing as the dates themselves. Northern Indian groups tend to show more recent admixture dates, and in many cases, multiple separate mixing events layered on top of each other over time. Southern groups, by contrast, tend to show older, single mixing events, a simpler and more distant history of blending. The researchers were careful about what this timing evidence could and couldn't prove. This data, on its own, does not establish a westward migration into India. It's a distinction population geneticists have had to repeat publicly again and again, precisely because the dating evidence gets so easily misread as proof of a specific migration narrative, when it only really speaks to timing. There's a firm historical bookend sitting underneath all of it. Before roughly 4,000 years ago, the data shows no detectable mixture at all between these two ancestral populations, anywhere in India. ANI and ASI, for all their tens of thousands of years of separate history, stayed genetically distinct right up until that point. Then, around 3,500 years ago, a third population entered the picture entirely. The scene shifts to one of the largest ancient DNA efforts ever assembled for this part of the world. In 2019, Narasimhan and his co-authors published a paper in Science built on ancient DNA, drawn from 523 individuals spanning Central and South Asia, a dataset whose sheer scale gave researchers a resolution previous studies simply couldn't match. From that dataset, the paper proposes a two-wave model for how South Asia's ancestry actually formed. First, IVC-related ancestry, the combination of Iranian farmer and ASI components discussed earlier, spread widely across the subcontinent. Then, in a separate and later wave, steppe pastoralist ancestry arrived from the north, arriving roughly between 2000 and 1500 BCE. One of the paper's findings carries particular weight for understanding modern Indian society. The amount of steppe ancestry present in a population correlates with that population's traditional position in the caste hierarchy. Groups historically classified as upper caste tend to carry more steppe ancestry than other groups within the same region, a genetic signature running parallel to a social structure built over thousands of years. That correlation isn't an abstract statistical curiosity for this episode. It's exactly what shows up when comparing steppe percentages across different Gujarati communities, a pattern later segments trace in specific named groups. The paper also maps out a plausible corridor for how this migration connects to language. It traces a route for Indo-European language spread into South Asia, running from Eastern Europe through Central Asia, arriving in the subcontinent in the first half of the second millennium BCE, tying genetic movement directly to linguistic history. Worth flagging clearly, this steppe wave is genetically and chronologically distinct from a much later, much smaller Iranian migration, the one that eventually brought the Parsis to Gujarat, covered later in the episode. Two separate Iran to Gujarat stories, playing out thousands of years apart, easy to conflate, but genetically nothing alike. That caste-correlated steppe signal is where Gujarat's individual communities start looking genetically different from each other. The lens narrows now to the single most studied Gujarati community in human genetics, the Patel surname, with particular focus on Leva and Kadva Patels concentrated across central and north Gujarat, communities that population geneticists have returned to again and again. The ancestry breakdown for this group is specific. Leva Patels typically show 50 to 60% ANI ancestry, a figure combining both the Iranian farmer and steppe components discussed earlier, alongside correspondingly higher ASI ancestry than most North Indian groups carry. Narrowing further to the steppe component specifically, Patel communities show roughly 8 to 15% steppe ancestry, a defined range that sets up a direct comparison with other groups. That comparison cuts against a common assumption. Punjabi Jats show 15 to 25% steppe ancestry, and North Indian Brahmin groups can reach as high as 30%. Meaning Patels carry meaningfully less steppe DNA than the North Indian groups pop culture routinely lumps them together with. There's a practical hook buried in these numbers, one that plays out constantly among Gujarati diaspora communities. It's the exact question people ask when consumer DNA results land in their inbox. My family says we're Leva Patel. Does the DNA back that up? Population-specific academic studies, not consumer kits, are what actually answer that question with any precision. Mainstream consumer tests routinely disappoint diaspora Gujaratis on exactly this point. Services like 23andMe or Ancestry DNA report broad South Asian categories, without the community-level resolution that academic datasets like these provide, leaving people with a continent-sized answer to a very specific family question. Move from the Patels to the Bania and Jain trading communities, and the ancestry profile flips. The pivot moves directly to Gujarat's Bania and Jain communities, groups that include Shvetambar and Digambar Jains, along with the Kapol and Oswal Bania subgroups, names that carry centuries of trading history behind them. Their genetic signature stands apart from what's been discussed so far. These communities show very high Iranian farmer and IVC-related ancestry, relatively low steppe ancestry, and a moderate level of ASI woven through the mix. 3 components, in a ratio that looks different from nearly everything covered up to this point. Historically, that pattern suggests something specific. These communities likely descend from populations sitting closer to the genetic core of the Indus Valley civilization itself, having absorbed comparatively little of the later steppe migration wave that reshaped so much of the rest of the region's ancestry. That draws a direct line back to the Rakhigarhi genome discussed earlier, the 4,500-year-old woman whose remains carried Iranian farmer and ASI ancestry with 0 steppe DNA. These modern trading communities' ancestry profile sits closer to that ancient individual than most other Gujarati groups do, a genetic echo carried forward across 4.5 millennia. The pattern isn't confined to Gujarat's borders either. Oswal and Maheshwari communities from Rajasthan, historically connected to Gujarat through centuries of shared trade, show a similar genetic pattern. That cross-regional consistency reinforces that this isn't coincidence. It's a trade network genetic signature, carried along the same routes that carried goods and capital. Endogamy is the mechanism that held it all in place. Centuries of marriage confined within these specific trading communities is what kept this distinct genetic profile intact, unmixed, and traceable all the way to today's sequencing studies. Not every Gujarati community got to stay that genetically undisturbed. The fact lands cold. The Koli community offers a direct contrast case, having occupied a historically different position in Gujarat's social hierarchy than the Patels or the Banias discussed so far. That difference ties straight back to the caste correlation finding raised earlier through the Narasimhan research. Communities with different historical caste positioning show measurably different steppe ancestry proportions, even within the exact same region. Gujarat itself becomes the control group for that finding. One state, multiple distinct genetic signatures split along old social lines. The mechanism behind that pattern deserves plain explanation. It isn't that different castes represent different races in any biological sense. It's that centuries of endogamous marriage rules locked in whatever ancestry mix a given group happened to carry at the moment those rules solidified, freezing a genetic snapshot in place and letting it persist largely unchanged ever since. A 2017 phylogenetic study from D'Cunha and colleagues adds another layer to this picture. Their research found Gujarati samples clustering distinctly away from Dravidian language-speaking populations from Karnataka and Kerala, while showing genetic proximity to European populations, a pattern the researchers linked to broader North Indian genetic influence running through the region. That same paper included an important caution, one worth stating directly. The researchers explicitly warned that their data on Gujaratis may not be representative for Indians on the whole, especially not for southern Dravidian-speaking populations. A reminder that even studies focused specifically on Gujarat can't speak for the rest of the country. What this means for the episode's larger claim is straightforward. Caste, language, and geography all left separate, measurable fingerprints inside the DNA of a single state. Endogamy did something even stranger 9 centuries ago than it did to the Kolis or the Patels. The scene opens in the 7th century CE, as the Sassanian Persian Empire falls to Islamic conquest and a small group of Zoroastrians flees by sea, sailing toward the Gujarat coast in search of somewhere to rebuild. The story that survives from that arrival is the Kissa-e-Sanjan. Local ruler Jadi Rana reportedly sent the refugees a cup filled to the brim with milk, a wordless signal that his kingdom was already full and had no room for newcomers. The Zoroastrians, in response, stirred sugar into that same cup and sent it back, their own wordless answer. They would sweeten the kingdom, not displace anyone already living in it. The settlement that resulted from that exchange became Sanjan, in present-day Gujarat, the first Parsi settlement established in India. The genetic record behind that story comes from Thangaraj and colleagues, publishing in 2017, who analyzed 174 modern Indian and Pakistani Parsi DNA samples alongside ancient skeletal remains excavated from the Sanjan Dokma, the Zoroastrian Tower of Silence, unearthed in 2004. The population scale of that community today is strikingly small. Roughly 69,000 Zoroastrians remain in India, making Parsis one of the smallest ethno-religious groups ever genetically studied at this level of resolution, a population small enough that researchers could trace individual lineages with real precision. The Y chromosome finding from that research is unambiguous. Paternal lineages in Parsis are described as strictly Iranian, a genetic signature that has held essentially unchanged for over 1,000 years. passed down father to son across dozens of generations since that original sea crossing. The maternal side of that same community tells a completely different story. The divergence is stated plainly from the outset. While Parsi Y chromosome DNA remains almost exclusively Iranian, mitochondrial DNA analysis of the ancient Sanjan remains found 48% South Asian-specific maternal haplotypes, a number that sits in sharp contrast to the strictly Iranian paternal line. In plain terms, that combination tells a clear story. The original Zoroastrian migrants were disproportionately male, and after arriving in Gujarat, they assimilated local Gujarati women into the community, building families that carried Iranian paternal ancestry alongside South Asian maternal ancestry from the very first generations. The genetic legacy of Zoroastrianism study puts a specific window on when that intermixture occurred, dating it to between 690 and 1390 CE, a span stretching roughly 7 centuries beyond the initial Sanjan settlement, meaning this wasn't a one-time event but a process that continued for generations. One specific maternal marker adds further texture to the picture: the HV2A haplogroup, identified in at least one ancient Parsi individual, a lineage marker known to have originated in Iran. Even on the maternal side, where South Asian ancestry dominates overall, this one lineage offers direct genetic confirmation of Persian ancestry surviving intact. The mechanism that preserved this specific mixed signature for over a millennium is endogamy again, strict marriage within community practices, still culturally enforced today, which are what let researchers trace priestly family genealogies genetically back toward that original Iranian arrival with such clarity. Framed against the wider story this episode has been building, Parsis stand as a live demonstration of exactly the male-driven migration plus local assimilation pattern researchers suspect happened repeatedly across South Asian history. Here, though, it isn't a matter of inference. It's dated, documented, and confirmed within the genome itself. 1,000 miles south of Sanjan, Gujarat has another migration story built the opposite way around, driven by force, not flight. The scene shifts to the Siddi community, found today mainly across Gujarat, Karnataka, and Andhra Pradesh, with a combined population numbering roughly 0.25 million people. The historical route into India stretches across centuries. The first documented Siddi presence in India dates back to 1100 CE. By the 13th century, substantial numbers were being brought into the region by Nawabs and sultans, serving as soldiers and enslaved laborers. The major influx, though, came later, arriving during the 17th through 19th centuries through the Portuguese slave trade, a system Portugal did not formally end until 1869. Not a myth passed down in oral history. A documented, dated, genetically confirmed population. The genetic confirmation of that history comes from Narasimhan and colleagues, publishing a genome-wide study in 2011 in the American Journal of Human Genetics, focused specifically on Siddi samples drawn from Junagadh district in Gujarat. Their ancestry finding is direct, roughly 70% African ancestry, combined with 30% Indian and European ancestry, a ratio that places Siddis among the most genetically distinct communities found anywhere in the state. The paternal lineage record adds further specificity. Research from Shah and colleagues in 2011 identified the Bantu-associated E1B1A1M2Y haplogroup in 34% of Gujarat's Siddi men, alongside the sub-Saharan BM60 haplogroup found in another 35%. Two distinct African paternal lineages accounting for the majority of male ancestry in the community. The maternal side of that same population carries an even higher African signal. The maternal figure lands cold. The African-specific mtDNA haplogroup L was found at 53% frequency within Gujarat's Siddi population, a rate notably higher than the 24% recorded in Karnataka's Siddi community. Two populations sharing a name, but not sharing an identical genetic history. That regional gap has a clear historical explanation behind it. Separate ports, separate slave trade routes, and separate patterns of local assimilation produce two genetically distinguishable Siddi populations within India itself, not one uniform group scattered across different states. Geography and trade route history split what looks, on the surface, like a single community, into two measurably different genetic profiles. There's a medical genetics angle folded into this same population. Researchers found roughly 10% African-specific genetic signatures in Siddis linked to protection against malaria, a functional trace of African ancestry that isn't just historical trivia. It's still actively shaping health outcomes in living people today, a biological inheritance doing real work generations after the migration that brought it. The estimated timing of admixture adds further precision. Siddi populations are estimated to have begun mixing with neighboring Indian communities roughly 200 years ago, about 8 generations back. A timeline that lines up closely with the historical slave trade and soldier recruitment records already covered. There's an asymmetry in that mixing worth flagging directly. Indian-specific genetic signatures show up inside Siddi populations, but the reverse pattern doesn't appear. Gene flow moved into the Siddi community from surrounding Indian populations, not out of it into neighboring groups. A one-directional signature researchers can trace with confidence. Set against the Parsi story from 2 segments earlier, the contrast is sharp. One migration arrived by choice and assimilated through marriage on largely equal terms. The other arrived by force and assimilated under an entirely different set of social pressures. Yet both left a permanent, traceable genetic signature inside the same state. 2 opposite histories converging on the same kind of evidence. Forced or chosen, every one of these migrations eventually ran into Gujarat's oldest social mechanism, endogamy. The fact lands cold. Back in 1986, Bernstein, Wadi, Rosendorf, Wessels, and Jenkins published a study in Human Genetics documenting an inverted Y chromosome polymorphism specific to Gujarati Muslim men from Kolvad village and its neighboring villages, a marker isolated to an almost impossibly small geographic footprint. The mechanism behind that isolation is straightforward. This specific chromosomal inversion was preserved and perpetuated across generations purely because of strict endogamous marriage confined within that village cluster. Not a mutation that spread outward, a marker that stayed locked exactly where it started. That finding connects to a wider tribal genetics picture, drawn from a separate study covering 284 men across 9 groups of Indo-European-speaking tribal populations in southern Gujarat. That research found none of the groups fully admixed, and none fully isolated, but it did find elevated genetic diversity pointing toward early, separate demographic expansions among these tribal communities. Why this matters for the larger argument running through the episode is direct. Endogamy is the mechanism that turned every migration covered so far, Steppe, Persian, African, trade network, into something still measurable in living people's DNA centuries or millennia after the fact. Without that marriage pattern, these signals would have blended and diluted long ago into statistical noise. There's a double edge to that mechanism worth stating plainly. It preserves valuable historical signal for researchers trying to reconstruct migration history. But it's also exactly what public health geneticists have to account for when studying disease risk inside these same communities, since the same isolation that preserves ancestry markers also concentrates whatever health-related variants happen to be present at the time. That disease risk angle produced its own distinct genetic discovery in Gujarat. The fact lands cold. In 2014, a study led by Rashidunisa Begum drew on samples from more than 1,500 vitiligo patients across Gujarat, findings that were later reported in the Times of India. The finding itself was specific. Researchers identified a particular SNP variation in autosomal DNA associated with vitiligo susceptibility within the sampled Gujarati population, a concrete genetic marker tied to a visible, well-known skin condition affecting thousands of people across the state. This kind of population-specific disease genetics matters for reasons that go beyond simple ancestry curiosity. The same endogamous history that preserves ancient ancestry markers, the kind traced throughout this entire episode, also concentrates disease risk variants within specific communities, turning marriage patterns centuries old into a factor still shaping modern health statistics. That practical value carries forward directly. Population-specific genetic studies like this vitiligo research are what eventually allow more targeted screening and treatment approaches, built specifically for the communities carrying the variant rather than generic, one-size-fits-all medical guidance. None of this kind of applied genetics research happens in a vacuum. It depends entirely on the same regional population studies covered throughout this episode and the Gujarat-specific genetic database that both this vitiligo research and the 2026 mtDNA study draw from simply didn't exist a generation ago. The infrastructure for this level of precision is recent, built study by study, sample by sample. The broader pattern here is worth stating directly. Ancestry research and medical genetics in Gujarat aren't separate fields operating on parallel tracks. They're pulling from the same underlying data set of who descends from whom and how recently that descent occurred. All of that layered ancestry didn't stay inside Gujarat's borders. The pivot returns to the GIH, Gujarati Indians from Houston, the reference population drawn from the 1000 Genomes project discussed earlier in the episode. Its inclusion carries a specific implication worth restating directly. For over a decade, global genetics research has used a diaspora Gujarati sample, not a Gujarat resident one, as its working definition of Gujarati DNA. There's real historical weight behind why a Houston-based Gujarati sample exists at all. Centuries of Gujarati trade and settlement history run through East Africa, through Kenya, Uganda, and Tanzania, long before the 20th century movement onward toward the UK and North America that eventually produced communities like the one sampled in Houston. That history creates a layered irony worth sitting with. A community already genetically shaped by Persian, African, Steppe, and Indus Valley civilization ancestry inside Gujarat itself, then went on to build entirely new diaspora communities across multiple continents, adding fresh layers on top of a base that was already deeply layered to begin with. A SatNav biogeography study adds further resolution to this picture, comparing GIH against 4 other South Asian populations sampled through the 1000 Genomes project: Punjabi, labeled PJL, Telugu, labeled ITU, Sri Lankan Tamil, labeled STU, and Bengali, labeled BEB, using nearly 495,000 SNPs to map the genetic relationships running between all 5 groups. What that comparison established is direct. Gujarat's genetic profile is measurably distinct from each of those other regional populations, reinforcing that South Asian as a single genetic category flattens real, documented regional differences that this kind of fine-grained comparison can actually resolve. Every thread traced across this episode, Patel, Bania, Parsi, Siddi, Koli, Kolvad, now also exists in diaspora form, carrying that same layered history forward into entirely new populations scattered abroad. Which brings the whole picture back to one uncomfortable word: single. The fact lands cold, laying out the full stack in order. A 40,000-year deep maternal layer sits at the base. On top of it, an Indus Valley layer combining Iranian farmer and ANI-ASI ancestry with 0 steppe contribution. Above that, a steppe layer arriving between 2000 and 1500 BCE, correlated with caste position across the region. Then a 7th century Persian layer, preserved almost entirely through Parsi endogamy. And finally a 12th to 19th century African layer, preserved through Siddi endogamy. One mechanism ties every layer of that stack together, and it's worth restating plainly: endogamy. The Gujarati Muslim Y chromosome inversion locked inside Kolvad village. The Parsi priestly genealogies traceable back to Sanjan. The Siddi 70-30 ancestry split. The Patel versus Bania steppe gap. Every one of these signatures survived specifically because communities married within themselves for centuries after each migration first arrived. Not one Gujarati genome, 6 or more, still readable, still separate. Worth naming honestly what sometimes gets framed as scientists refusing to talk about this complexity. It's less refusal and more a genuinely difficult communication problem. Journals like the American Journal of Human Genetics and Cell publish this level of nuance constantly, but it rarely survives translation into a single-sentence headline or a consumer DNA report built for a general audience. What's genuinely still unresolved deserves equal honesty. Exact founder population sizes for several of these groups remain uncertain. Ancient DNA coverage for pre-IVC Gujarat is still incomplete, and researchers still lack finer resolution on exactly when Siddi communities in Gujarat and Karnataka diverged from one another. This is normal, active science, not a closed case. New papers, including the 2026 Desai and Singh mtDNA study that opened this episode, are still actively rewriting parts of this picture, meaning the final word on Gujarati ancestry doesn't exist yet and isn't close to existing. That unfinished picture is exactly where this story has to end. Gujarati was never hiding one answer. It was always holding several, each one dated, sourced, and traceable, back through the research covered across this entire episode. The emotional anchor of all of it remains that single skeleton at Rakhigarhi. Over 100 failed extraction attempts and one successful genome that rewrote the region's oldest chapter, pulled from a woman who died 4,500 years ago and never knew her remains would eventually answer questions her entire civilization couldn't have imagined being asked. Underneath all the studies, the haplogroups, and the percentages sits something more human. For Patels, Parsis, Siddis, and every other community named across this episode, these aren't abstract statistics sitting in a journal. They're documented answers to exactly the kind of family history questions people carry quietly for generations, waiting for confirmation that finally arrived in the form of a lab result. What's still unanswered deserves to be said plainly, without inventing false certainty where none exists. Precise founder dates for several of these communities remain out of reach. Deeper ancient DNA sampling that could resolve remaining questions simply hasn't happened yet. If one state can hold this many separate, provable histories, what does that say about every other single-word ethnic label we've stopped questioning? Sit with that question. It doesn't need an answer tonight.